So you're welcome to join me there. You're welcome to just stay where you are and uh, and watch. Okay, so this was the first suggestion that Lee had for solving the Cleisthenes Hippias Solon problem. Now, for those of you who forget what that problem is, there's three rules. The first rule is that Cleisthenes has to win the election. That means that if we add up all of Cleisthenes, all of the votes from Cleisthenes, that has to be more than Hippias, and Hippias has to come second. So Hippias has to get more than Solon. Okay, so many people can't go there, so that's okay. We're just going to do it here. I'm experimenting with all of these new technologies, so we'll figure that out later for another day. That's the first one. So Cleisthenes has to win, Hippias second, Solon third. The second thing is that more people have to vote for Cleisthenes than vote for Hippias. And more people have to vote for Hippias than vote for Solon. And then the last rule of this election, what happens after the votes are counted, we find that if anybody that voted for Cleisthenes moved over and voted for Solon instead, then Solon would win the election. So we have to look at all three of those criteria and see if this is a success. So certainly, if we add up all of those from Cleisthenes, we get 25, 26, 27. So Solon, we add those ones up and we get 25. From Hippias, we get 26, and for Solon, we get 27. So according to the first rule, everything is okay. Okay, Garcia, can you tell me, write down the rule that you had just in the chat. Okay. So this is good. For the first criteria, 27, 26, 25, Cleisthenes is 1, Hippias comes second, Solon comes third. The second rule, certainly there's more people voting for Cleisthenes, 5 to 4 to 3. So again, we're happy. The third rule, can we move over any of these and any of these people from Cleisthenes to Solon, and then Solon wins? Unfortunately not. In this case, we have a three-way tie. It is not a victory for Solon. This is 26, 26, 26. So Lee, this was a very close, I don't think Lee actually joins us on this. I think he just watches videos from the Math Pickle website later. So this is a fail. But if you're joining us, Lee, today, this did not work. But I thought that Lee's attempt was so good. Like the idea was really cool. Like he split everything so evenly, 27, 26, 25. I thought that is probably a really good basis to solve the problem. So I would like you guys to think for 20 seconds silently and see if you can solve it. 20 seconds silently. I'm going to turn off the chat. Well, I'm not going to turn off the chat because I want to read what Garcia wrote. Right. So Garcia's idea is that you can't have the 1 here, which kind of makes sense. So I'm not sure if there's a solution here with 1, but maybe not. Yeah, because this is the closest that they could possibly be. Cleisthenes, Hippias, Solon. This is the closest they could possibly be, 27, 26, 25. So Cleisthenes certainly cannot have the 1 there. So Garcia, I absolutely love your idea, and I think it's correct. Yeah. Yeah, so the two, so we need to get rid of this 1 here. So let's keep the 27, 26, 25. Let's swap out between Cleisthenes and Hippias, let's swap out two numbers that add to the same thing on Cleisthenes and two numbers that add to the same thing on Hippias. And if we can switch those, and one of the numbers in Cleisthenes has to be a 1. So if we swap out the 1 and move the 1 to Hippias. Yeah, I agree, but we have to move something back again because then Hippias would win. So yes, I agree. So ponder. Yeah, this is let me just go back, and this is the hardest of the 3 puzzles we're going to do today. But there's 3 things. We want to make sure that all the numbers in Cleisthenes on the 1, the 2, the 6, the 7, the 11, all of those numbers, whichever numbers we put there, they have to add to more than either the numbers in Hippias or the numbers on Solon. So that's the first thing we want to do. 1 and 11, 4 and 8. So let's try that. We're going to switch. Radar is saying we're going to switch the 1 and the 11, the 4 and the 8. Okay, let's see if that makes people happy. Okay, so ponder. Let's now just check. If you add up all of the numbers in Cleisthenes, what do you get? Okay, now we had done that before, but then we switched some numbers. But we were smart about switching. We switched numbers that added to the same thing. So it should be the same whenever you add up all of those. It should add up to the same. Let me just put these in order. Okay, should be the same. Yeah, it's 27. That's right. And Hippias, 26. So that's good. Cleisthenes has still won this election. The second thing that has to be true is that more people must vote for Cleisthenes. Is that true? Yeah. 5 people have voted for Cleisthenes, only 4 for Hippias, and even less for Solon. So that's good. And then Garcia's example, that we swap from Cleisthenes to Solon. We can swap any of them, and then Solon must win this election. In this case, Solon goes from 25 to 27. Indeed, Solon has won. So Lee did not quite solve this, but Lee plus Garcia's idea did solve it, plus Rader's idea of swapping which ones to swap there. So that was all good. Okay. Now, generally, we have now solved this for 3 people in the election. Of course, as a mathematician, I am always thinking, can this be solved for 4 people, a 4-person election? So that's what I'm going to go back home. Well, I'm in my home right now. After this, that's probably going to be something that I want to be thinking about. Can this be solved for 4? If so, what's the fewest number? Like here we did 1 to 12. Okay, and I think that's the least you can do. I don't think you can do 1 to 11 or 1 to 10 and solve this. I think it's impossible. So I think this is the first time that it's solvable whenever you're dealing with 1 to 12. I want to know, for 4 people, what's the least number that you need to solve that? I think I played with this before, and I think it might be 1 to 18, but I'm not sure. You know that I'm always forgetting. I record some of my results and some of my explorations, but then I forget stuff. So it's all fresh, whenever I go back and try to solve the puzzle again. Okay, next puzzle we are looking at is this one. We are going to be dealing with one new puzzle, and we're going to deal with it just after this, Raider. So this one here. This was a solution, again, by Lee, but he failed to put in the 1. Okay, so he was trying to solve actually from 1 to 9, but failed. But I thought this was interesting because we ended up last class trying to solve 1 to 8, and we failed to solve 1 to 8. Lee tried 1 to 9, and he failed. But how could we use this attempted solution to solve 1 to 8. Okay, remember the mountain bike problem. So the mountain bike problem, you cannot have 4 going up or 4 going down. So for example here, if I put the 1 at the end here, then unfortunately I have 9, 6, 3, 1. I've got 4 going down. Okay, so that's not an exciting mountain bike race. You want to have it more exciting than that. If I put the 1 over on this side, then that also doesn't work, because then I have 1, 7, 8, 9. So I have them going up like that. So this is really irritating. I can't put the 1 anywhere in here. If I put it in the middle, it also doesn't work. But how can I use this attempted solution, which is wrong? How can I use this to solve for the 1 to 8 problem? So Garcia, you've never seen this before. So, oh, and Moore, you weren't here either. Okay, so yeah, so that's the puzzle. Is that you have to find a way to organize these numbers so that there's no 4 going up and no 4 going down. Okay, and we struggled with this, and we failed. We managed to do it for 1 to 5, and we managed to do it, put 1 in the middle. So Ford says put 1 right in the middle. So I'm going to put these 4 like this, and I'm going to put these 4 like over here, and then 1 can go right in the middle. So Garcia and Moore, you weren't here, but can you solve this? Can you find, or can you show that this is not a solution? Can you say, oh no, we have not succeeded here because there's 4 going up or 4 going down? Schulke, 1, 2, 3, 4. Yeah, so that's pretty easy. There we go. 1, 2, 3, 4. Unfortunately, we have 4 going up like that. We also probably have another. No, that looks like the only way to beat it. Yeah. So Moore, correct. This is a fail. Okay. Garcia, you understand that this is a fail. But if we go back here, let's just get rid of the 1 entirely. Okay, now, how does this looks good. We don't have the 1 in there, but this looks good for 8. Oh, Moore says switch the 2 and the 1. Okay, just let me. Okay, got it. Okay, I will switch the 2 and the 1. So we'll go back to this solution here where I had the 1 in the middle, but instead of that, I'm going to switch the 1 and the 2. So maybe this does work. I never thought about that. Okay, what do you think? Okay, is this going to work, Garcia and Moore? Yes or no? Are we messed up or are we successful? You're not following, Moore. Okay, so can you find 4 numbers that go down or 4 numbers that go up? Okay, yeah, so go ahead, find 4 numbers that go down or 4 numbers that go up. I'll erase all of the other numbers just so you can see. Go ahead, yeah. Show that this is not a solution, because we can find 4 numbers that go up, 4 numbers that can go down. Go ahead, name it. Ponder, you can get in on this too. Name the 4 numbers that you see, because I don't think this works. 4, 3. If I go 4, 3, 2. Oh, but there's not a 1 over here, so I can't keep on going down. 7. Yeah, so 7, I'm going to erase everything else. So 7, 5, 2, 1. That's exactly right. So that is an example, Willis. 7, 5, 4, 1. Oh, you did a different one. 7, 5, 4, 1. Well, that wouldn't be in order. But Heatley said 8, 5, 2, 1. Yeah, so I can erase that one. 8, 5, 2, 1. Yeah, so that's, boom, it's going down. That's not acceptable. We don't like that one. Yeah. And there are other solutions, right? We could have chosen 7, 5, 2, 1. We could have chosen 9, 5, 2, 1. I think you need to have the 5, 2, 1 in there, right? Yeah, so I think there's 3 different solutions. Okay, so but by solutions, it's actually the reverse of a solution. You're actually breaking the solution. You're actually saying, no, this doesn't work. So yeah, there's nowhere to put that 1. It doesn't fit in there. So I'm going to get rid of it. But using that, can you solve 1 to 8 now? Can you find somehow, here we need to get rid of this 9, but can you solve the 1 to 8 problem? If we just put a 1 in here, is that good enough? It's not. But how can we use this solution for 2 to 9 to find a solution 1 to 8? Okay. So think about that for 5 seconds. Yes, Heatley, this does mean that 8 is possible. Absolutely. Because you've got 8 numbers in a row. And Raider is saying 7, 8, 9, 2, 3, 1, 2, 3, 1, 5, 4. So that might be true. But I was more looking, Raider, to use this solution. So I'm happy to put that up. And duplicate. So that's 7. So this is, whenever you guys are figuring out how to use this wrong solution, I'm going to put up Raider's solution. And then 2. Oh, but we want to get rid of the 9, right? Right. Okay. So that's not gonna work, Raider. Yeah, we're trying to get rid of the 9. We're trying to solve 1 to 8. Okay. Deckel has got an idea to solve for 9. So you're actually going to try to solve for 9. So I am not promising this is possible, but we can try. So that's 1. Okay. 2. Duplicate. No, it's 3, 2. So this is Deckel's solution attempt at the top here. 1, 3, 2. Okay. 1, 3, 2, 4, 7. Duplicate. 4, 7. 4, 7. 5, 6, 8, 9. 5, 6, 8, 9. Okay, so there's Deckel's solution at the top. And yeah, it doesn't look good. 1, 3, 5, 7. 1, 3, 4, 7. Yeah, so there we go. That's an example of a fail. So Deckel, that didn't work because 1, 3, 4, 7. Whoop. Okay. So I'm going to leave that up there in case anyone wants to try the 9 by 9. But again, I want to come back to this idea here. So I'm going to give you a hint. You've solved 2 to 9, but yes, so Raider's using 7, 8, 2, 3, 1, 7, 8, 2, 3, 1. So okay, let's do Raider's idea. 7, 8, 2, 3, 1, 2, 3, 1, 5, 4. Okay, and where's the 6 here? Oh, so that's not solving, Raider, that's not solving 1 to 8. That's solving 1 to 8 with the exception of 6. Okay, so I'm going to give you guys a hint. So what I saw in Lee's solution, this is Lee's solution on the middle here, that is 2 to 9, and he couldn't fit in the 1, so we've got rid of that one. But he did solve 2 to 9. So what can you do to make this 1 to 8? What can you do to this solution to make it 1 to 8? Yes, you can subtract 1 from everything. So we're going to subtract 1 from everything. So underneath this, underneath the 2, I'm going to put a 1. Underneath the 3, I'm going to put a 2. Underneath the 4, I'm going to put a 3. Underneath the 6, I'm going to put the 5. Underneath the 5, I'm going to put the 4. Underneath the 9, I'm going to put the 8. Underneath the 7, underneath the 8, I'm going to put the 7. Underneath the 7, I'm going to put the 6. So this is a solution to what we were looking at on Wednesday. 6, 7, 8, 4, 5, 1, 2, 3 solves the 1 to 8. Okay? So you always want to be thinking, oh, is there something simple that I can do? I've already got this solution. Is there something simple that I can do that can move it over to another solution? So in this case, it was just subtract 1. Yeah. So yeah, you've solved it. I'm going to leave it with you. Can you solve 1 to 9? Okay. So I'm not doing that today, but that will be for another day. Here we are back with our spaghettum problem. If you remember, I had, up here in Canada, we're struggling to get enough food, and so each day I get one piece of spaghettum to eat, and I dribble this over my plate, and I get to eat my one piece of spaghetti. Okay, remember that puzzle? So this is different. If you remember that one, all of the numbers were organized. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. They were all organized in a square. Here, your challenge. Now, how many people did not see the spaghettum problem? Okay, so I guess I should ask that first. Okay, so Maura, you didn't see that. So what I'm going to do is I am going to duplicate this, and I'm just going to go here. Good. I'm just going to refresh memories of this spaghetti problem, and I'm going to organize in the way that we did before. 7. Okay, so here they were all organized nicely. 9, 10, 11, 12, 13, 14, 15. So, Moore, what we did was we chose any number. Choose any number. Okay, I'll just take the first number that anyone chooses. Okay, and we're going to check if my spaghettum works. Moore chooses 5. So from 5, I'm just going to choose a paintbrush. Okay, nice red paintbrush. That's too weak. No, I'm not going to do that. I'm going to choose a nice marker. Maybe make it a black. Make it a red marker. Okay, so I start off with 5. I go up, left, right, or down to always choosing the smallest number on my plate. Okay, so 5, which is smaller, 1, 4, 6, or 9? Okay, big question, and it is, of course, the 1. So I'm going to move up to the 1. Now, I get to choose between going to the 0 or going to the 2. Which do I choose? I choose to go to the 0 because it's smaller. Now I have no choice at all. I go to the 4. Now I have no choice at all. I go to the 8. Now I have a choice. I can either go to the 9 or I can go to the 12. I'm going to go to the 9. Now I have a choice. I can either go to the 10 or to the 13. I'm going to go to the 10. I have a choice. I can either go to the 6, to the 7, or to the 14. I'm going to go to the 6. And I go to the 2, and I go to the 3, and 7, and 11, and 15. So I am so happy. If I start off with this number 5, I'm successful. I get to go through all of the plate. I get to lay down my entire spaghettum, and I don't have to cut it in 2. Like any Italian will tell you, you do not cut your spaghetti. Okay, you cannot cut. A single spaghettum is even more valuable. You do not cut. If you only have one spaghettum a day, you do not cut it. Okay, so that color, that number 5 is green. Okay, if you choose another number, it might be possible or it might not. So let's so that's what we're dealing with. Okay, now we are now going to go to the next page, because now we have a slightly different puzzle. Now we are allowed to turn those numbers, to switch them up, so we can change the 15 and the 0. We can move them all over. And the objective is, no matter where you start on your plate, you always must be successful. Okay, so a different puzzle. I want this whole plate to be colored green. So if we start with the 0, so I'm going to choose the marker. If we start with the 0, then very quickly I can just go like this. I can go down like this. I'm going to go like this and like this and like that. Okay, and I've succeeded. So 0 is going to be a success, so I can color that. Actually, just let me duplicate this page a few times. Okay, that's good. Okay, so that's 0. I'm going to color green. That's good. Okay, what do I do? Okay. Okay, let's try that again. There we go. Color it green. So that's right. That one's a green. Okay, so Garcia, the question is, why not spaghetti? Because spaghetti means that you've got more than one. But if you only have a single piece of spaghetti, shouldn't that be called a spaghettum? I think so. Okay, Snell, how does this game work? So you're starting off, name a number, any number. So Shulky says number 15. Let's see if it works. So from 15, let me just choose a different, let me choose this. So number 15, we have to choose the smallest one. The smallest number, 8, 10, 12, or 14, the smallest is 8. So I'm moving down there. Then, where do I go? 7 or 9, I'm going to 7. So you can see that what I'm trying to do is I'm trying to get the whole one finished here. So here I go, 6, 5, 4, 3, 2, 1, 0, 11. Then I have to choose between 12 and 10. That's 10, 9. And now I have to cut my spaghetti and do that. And that makes me sad. I don't want to be cutting my spaghetti up. I want to be eating my spaghetti I want to twist it around in my fork, and I want to eat it whole. Okay, so this is very disappointing for me, but no fear, I can switch around. So we know this puzzle immediately doesn't work. Okay, we need this to work for every number that we choose. So we know that the 15 can't go there, or we know some other number can't go there. Okay, so that's the question. Which numbers do you want to? No, light, we've already failed. This is already a failure. All of these numbers must work. So this is different from the original spaghetti problem, where we're just trying to figure out which ones work, which ones don't. Is there a pattern? This one, we're not interested in any patterns. We just want it always to work, no matter where I start putting my spaghettum. It has to work. Okay, so let's try to make this work. Which numbers do you want to switch? So you can just name 2 numbers and I will switch them. That would be one way to communicate with me. Nine and 12. Okay. So here we go. We are switching 9 and 12. Now let's. So this is Moore against everybody else. Okay. So Moore, you and I are together, and other people have to try to name a number which makes Moore and I fail. Go ahead. Ford says 14. Okay, so 14. Let's see if Ford beats Moore and me. So 14, that goes to 5. 5 goes to 4, 3, 2, 1, 0. Goes to 11. Then that goes to 9. Then to 13. And you're right. So Ford, you have beaten Moore and I. There we go. So again, I will see what people want to change. Light suggests 15 and 11, but that might be from the previous one. So I'm going to guess that's from the previous one. So it was like this. I'm going to guess that Light wants to switch 15 and 11 like this. Okay, now Light and I are against everybody else. Name a number which you want to try. Snell says 15. Let's see if 15 fails. This is Snell against Light and I. That's right. Okay, 15. The smallest number around 15 is 0. We go up to 0. Then we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And that one worked. That one's okay. So yeah, choose another number that doesn't. Okay, or else Light and I are going to win. Okay, so I'll give you guys 2 more chances to come up with a number that doesn't work. Schulke says 10. So 10 goes to 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. That goes to 15, 12, 11, 14, 13. Again, a success. I will give you 1 more chance. 1 more chance to solve this. Okay, we have 12. Ford is saying 12, or Heatley's saying 7. Okay, I'll give you 2 more chances. 12 goes to 1. Then 1 goes to 0, to 15, to 10, 9, 8, 7, 6, 5, 4, 3, 2, and 12 works. Oh my gosh, this looks good. Okay, Heatley is saying 7 with a question mark. 7 goes to 6, 5, 4, 3, 2, 1, 0, 15, then 15 goes to 10, 9, 8, 11, 12, 13, 14. Oh, Light, we are doing well. Oh, many people are saying 6. Many people are saying 6. Okay, 6, 5, 4, 3, 2, 1, 0, 15, 10, 9, 8, 7, 14, 11, 12, 13, and it is another victory. Light and I are on a roll. Life is looking good. You guys are being crushed. Here we go. Okay, are we ready? 11. Herndon says 11. Moore agrees. 11 goes to 8. 7, 6, 5, 4, 3, 2, 1, 0, 15, 10. I have to cut my spaghetti. Okay, so Light, like, I think we should get many points there, don't you? Like, we busted them for like 5 or 6 attempts. So I'm going to say that we get a half victory. Okay, there we go. So that also didn't work. Okay, so we failed. Go ahead. Choose some numbers to alter, and let's see if anyone can beat Light and I. Yeah, I think that's a good way to do it. Like, I think we survived like 6 attempts at choosing numbers. 13-0. So this is Schulke and I will be against everybody. We're going to switch 13 and 0. And you guys try to beat Schulke and I. Willis says 8. Okay, here we go. Starting off with 8. We go 7, 6, 5, 4, 3, 2, 1. Then we go to 12, then 0, then 14, 11, 10, 9. Yeah, Willis, you destroyed us. Not good. Ford. Yeah, you've already destroyed us. So now we're again ready to switch to Heatley. So it's going to be Heatley 9 versus 8. We're going to switch 9 and 8. Here we go, 9 and 8. So this is Heatley versus the rest of the world. Heatley and I. Here we go. Are you ready, Heatley? Okay. Number 2. Here we go. 2 goes to 0. 0 goes to 0 goes to 4. 4 goes to 3. Oh my goodness, that was that's kind of bad because now I have to start over here. 1, 12, 11, 9, 7, 6, 5, 14, and I have to start again. 8, 10, 15, 13. You know what? I've just thought of a totally different puzzle. What happens the opposite? What happens if you have some cretin out there who insists on cutting the spaghetti as many times as they want, as many times as they can? So here, I've never before had a solution so bad, but that's kind of interesting. Yeah, I actually like this puzzle. So this is a brand new puzzle. Yeah, brand new puzzle created right here. Can you guys, maybe we should do that instead. Come up with something that better. So maybe I am going to say, who did that with me? This is Heatley, right? So Heatley, you and I are winning right now because we've created the spaghettum that requires the most cuts. Yeah, so we're just going to change this puzzle right in the middle. Right in the middle, we're going to change it. And now you guys have to beat this. Is there any way to find a puzzle that has more than 3? Yeah, so anyway, both are interesting. So I'll let you guys choose which you want. Do you like to do you want to continue with trying to find a solution where everything works, or do you want to keep on exploring, see if you can find the worst possible solution where you have to cut the spaghetti not once, not twice, but maybe this one I had to cut it once, twice. I had to cut it twice to make 3 different parts to the spaghetti. So is there a way to make me have to cut it more? I don't know. Yeah, maybe we should just maybe. Wow. Okay, I'm just blathering here. Okay, so let's just continue. I'm going to perfect that puzzle and present it at a later date. So we're gonna keep on going. So Heatley and I lost. Yeah, let's just forget it. I love being creative, but maybe it's not the right time. So we're just going to go back. Heatley and I lost. So switch up any 2, and then everybody else is going to be against us. So I think we already failed. But if Ford starts at 4, then we go to there. 4 to 0, 2, 1. Okay. And from 1, I go to 12, and to 12 to 11, 10, 9, 8, 9, 7, 6, 5, 14, 13, 15. Okay. Oh, yeah. But then I also have this little 3 over here. Yeah, so that's also 3. Took 3 to solve. Anyway, clearly Heatley and I have lost. So Willis, it's now Willis and I against the world. Willis is suggesting a change between 6 and 13. 6 and 13. This is Willis's idea. Okay, Willis and I are against the world. Dubowski, name any, in order to defeat Willis and I, you need to name a number where I cannot lay my spaghetti, lay my spaghettum, in such a way that whichever number I start at, and you choose that number, Dubowski, whatever number I start at, I have to always choose the nearest number that is smallest. Okay? So, for example, Moore here is saying if I start at 12, I have a problem. So if I start at 12, I go to the lowest number. I can go to either 1, 0, 11, or 15, which is the smallest, the 0. So I go to 0 first. Now I have to choose between going to the 2, the 4, or the 14. I'm going to choose the 2. I now have the choice between the 1 and the 3. I'm going to choose the 1. 6, 15, 10, 8, 9, 8, 7, 13, 5, 4, 3. And yes, Willis and I have been defeated. We are out of luck because we've had to cut the spaghetti. We could not do it in 1, starting at 12. So frustrating. Next person. Go ahead. Yeah, I know. Well, it's disappointing. That's life. Like Ford has found a pattern. Okay, so okay, let's have another idea here. Is there any way to 0 and 15? Deckel is switching 0 and 15. Where's the 15? There we go. Okay, Deckel and I are against the world. Go ahead. Okay, every even number is a fail. So this is a Ford idea. Every even number is a fail. Okay, let's see if that is true. If I start with 0, which is even, then that would go to 6, 1, 2, 3, 4, 5, 13, 7, 9, 8, 10, 11, 12, 15, 14 is a success. So Ford, I love the idea that you have a hypothesis. Whether that hypothesis is wrong or right, that is the right way to approach mathematics. You want to be having these hypotheses and then shooting them down, and you had a hypothesis and you shot it down. That's great. It's wrong. It's gone, but it was great. So we've already failed on this one. If we start with 2, then it goes to 1, then to 6, 0, 10, 8, 9, 7, yeah, boom. And this one is a fail. Yeah. So that if you start at 2, it's a fail. So that would have supported Ford's hypothesis. But the only thing we need is to find one example which doesn't work, and Ford's hypothesis is gone. And for 0, it didn't work. So we know it's not right. Okay, let's change up. We've already been defeated, sadly. Oh, in the old pattern of numbers, Ford was saying, not for any pattern, for the old pattern. Okay, that's possible. Moore, so this is going to be Moore and I against the world. 8 and 11 are being swapped here. Here we go, 8 and 11. Moore and I against the world. Go ahead, people. Okay, Willis. Oh, okay, no, now we're going to be, it's Moore and I against the world. So number 8, let's see if number 8 does it. So that's 8 goes to 9, 9 goes to 7, to 13, to 5, 4, 3, 2, 1, 6, 0, 10, 11, and yes, we are in trouble. We are in trouble. So Moore, we crashed and burned. That didn't work. Okay. So back, Moore is suggesting switching 10 and 12. But let's have somebody else. Well, I'll pair up with somebody else to try to defeat the world. Ford, I'll pair up with you again. 3 to 6. Here we go. 3 to 6. And go ahead. So go ahead. Try to find something that breaks that. Yeah, so next time it's going to be you, Herndon. But try to solve this first. How on earth are we going to stop this? How are you guys going to try to stop it? I'm okay. 9. Shulky says 9. So let's see if 9 works. 9 goes to 7. 7 goes to 13. 5, 4, 6, 2, 1, 3, 0, 10, 8, 12, 15, 14. Perfect. Oh, no. We forgot the 11. Ah! Oh, no. Yeah. So that didn't work. Okay, Herndon, which 2 do you want to switch? I don't think I've paired up with Herndon yet. So which 2 numbers do you want me to switch here? $12 and 8. Okay, 12 and 8 it is. I am switching 12 and 8. There we go. And which number are you guys going to try to beat Herndon and I? Ford says 7. Let's see. 7 goes to 9. 9 goes to 11. 10 0, 3, 1, 2, 6, 4, 5, 13. Yeah. 11 did it. Yeah. So I am going to leave you guys with this puzzle. How are you going to find how to organize all of those numbers, all the numbers 0 to 15, so that no matter where I put the spaghettum, start the spaghettum, I always win? Is this an easy puzzle? Nope. um, but I think it's fun. Okay, you guys take care. I'm thinking of you, and I will see you on Monday. And yeah, I hope this sad part in life gets over fast and we get back to a reasonably normal way of existing and being able to see one another and hug one another and being with one another. You take care, and I will see you on Monday. Bye-bye.